Let's go to page 31 and start with number 1. Okay, so you have this triangle over here with A, B, C, and theta. Okay, so number 1, you're looking for cosine theta. So cosine is adjacent over hypotenuse, so it would be A over C. Okay. Number 3. Number 3, you have tangent theta. Tangent theta is opposite of adjacent, so it would be B over A. Okay, number 5, secant theta. Secant is the reciprocal of cosine, so cosine is A over C. Okay, so secant would be reciprocal of that, so it would be C over A. Okay, number 7. Number 7 is going backward, so B over C. Okay, so B over C, so this would be sine theta. Okay. Okay, I'm going to do it on here, over here, so you can easier to see the picture. Okay, number 9, B over A. So B over A, this is the tangent theta. Okay. Okay, number 11, C over B. So C over B, that's a reciprocal of sine. Sine is B over C, so C over B is 1 over sine, and so be cosecant theta. Okay, let's go to the next one. Okay, number 13. Okay, you want to convert the ratio into three significant digits. So you got sine of 34.7 degrees. So this one you want to use calculator and just enter. Okay, so this is degree, so make sure you calculate in the degree mode. Okay, and so you got 34.7, and you take the sine of that, and this will equal to three significant digits, so it will be 0.569. Okay. Okay, number 15. You have tangent of 29 degrees, 45 minutes. Okay, so again, make sure you know how to use your calculator. So you enter 29.45, and you have to convert into decimal degree. And then you take the tangent of that. So it would be 0.572. Okay, next one, number 17. You have secant of 42.2 degrees. Now, if you look on your calculator, there is no secant function in here. So what you need to do is, first you have to make it this equal to 1 over, secant is 1 over cosine. Okay, so you have to do that. Okay, so again, depends on your calculator. So for my calculator, I have to enter 42.2, I have to do the cosine of that, and then I have to flip it over. So I use the 1 over x button to flip it over. Okay, and so this will equal to 1 point, and let me see, 3 significant digits. So it would be 1.35. Okay. Okay, number 19. Cosine of 83.4 degrees. Okay, so this one is straightforward. You just enter that. So 83.4 cosine, and this would be 0.1149, so it would be 115. Okay, 21. Okay, 21 is cotangent of 66.7 degrees. So again, so this is a secondary function, so you have to convert into primary function. So this is equal to 1 over tangent of 66.7 degrees. Okay, so for this one, again, I have to enter the number first, so it will be 66.7 degrees. Take the tangent of that, and it's 1 over, so 1 over that will give you 0.43 0.6 will become 1. Okay, so it'll be 0.431. Okay, let's go to 23. Okay, you have cosecant of 81 degrees and 20 minutes. Okay, so there's no cosecant over here, so you have to convert into primary function. Cosecant is 1 over sine. Okay, so now you can use that. So you enter 81.20 and convert into decimal degrees. Then you take the sine of that and you flip it over. Okay, so this is equal to 1.01115. So again, 3 significant digits would be 1.01. Okay. Okay, let's go to the next one. Number 25. This one is going backward. You're looking for angle. So you're looking for cosine of theta equal to 0.5. Okay. So you're looking for the nearest degree. Okay, so whenever you're looking for angle, you have to go second function. So you enter 0.5. Okay, and you have to go second cosine of that, and so this would be 60 degrees, so theta equal to 60 degrees. Okay. Okay, and let's go to the next one, number 27. Sine theta equal to 0.8125 and to 2 decimal places. Okay, so 0.8125 equals second sine, and so theta equal to 2 decimal places, so it'd be 54.34 degrees. Okay. Okay, 29. So theta equal to arc sine of 0.4517. Okay, so arc sine is same as the, again, whenever you're looking for angle, basically means you have to use second function, okay? So you again, just enter the number, so you're going to get, okay, so over here you're going to enter 0.4517, and again, arc sine means the secondary function, it's an inverse sine, so it goes second sine, and so theta equal to 29 to the nearest 10 minutes. Okay, so we got decimal degrees, so you have to convert into DMS. So go convert to DMS. So, and you want it to the nearest 10 minutes. Nearest 10 minutes. So this is 26 degrees and 51 minutes, but you want it to a nearest 10 minutes, so it'd be 50 minutes. Okay, next one, 31. Theta equal to, so they're all the same thing. So arc sine, so you write arc and or the -1 on the exponent. So this is like inverse function. This is not the exponent, okay? Just be aware of that. 2.753 to the nearest minutes. Okay, so again, you start with 2.753, you go second 10, and then so that's your degree, and then you convert into DMS and to the nearest minute. Okay, nearest minute. Okay, so you got theta equal to 70 degrees. Nearest minutes would be 0.2 minute. Okay. Now if you don't have 0 over here, that's fine too. Okay, so you can have just the 2 without a 0. Okay. So if you write this way, so that's fine too. Okay. This probably looks more normal. This is more like a calculator display. This is more like a normal writing. Okay. Okay, number 33. So you have a triangle, and you have the A, B, C. Okay, so you only indicate why you can or cannot solve the triangle. Solve the triangle means you're looking for all three sides and three angles. So actually, if this is A, let's do this. A, this is B, and this is C. There you go. Okay. So if you're giving the A, so if you know this one and if you know this one, then you can solve the triangle. Okay. So basically, what you need to do is to solve for C, you can use Pythagorean Theorem. So use Pythagorean Theorem, you can find C. And then you can use the A, so you can use cosine. So you can use the sine. So sine A equal to A over C, and then you can find that. You can find A. Once you find A, then you go 90 degrees minus A, this will give you B. Okay? So you can able to solve, you're able to find everything. Okay, okay, now 35. Okay, you get a measure of two acute angles. So if you're giving these and these, okay. So the problem is you cannot solve this triangle, okay, because you don't know any side. So all you have is three angles. So this have infinite number of combinations because you can have a triangle this big, okay. You can have this triangle this big, okay, so you can have all similar triangles with the exactly same angles, okay. So you can have that, okay. So there's no unique right triangle for it. Okay? So by just knowing all three angles, you're gonna get infinite number of possibilities. Okay? So you're not gonna be able to solve this triangle. Okay, so it says using the label, the picture in the beginning. So you have this picture over here. And so this is theta, and this is A, B, C. So in this case, so small a is over here, so the big A would be over here. This would big B, and this would big C. Okay. So solve the right triangle. So when you say solve the right triangle, means you're looking for all three sides and all three angles. Okay. And so what we're gonna do this: A, B, C, A, B, C. So again, when it's solving means doing all these. Okay. Okay. So theta is the B. Right, see the theta over here? So that's the angle B. So this is 58 degrees and 40 minutes. Okay, angle C is a right angle, so we know it's 90 degrees. Okay, and C is given, so this is 15.0 millimeters. Okay, so that's what we did. Okay, so what you can do is you can just go and, so A and B equal to 90, so use 90 minus that will give you 31 degrees and 20 minutes. Okay. And once you do that, then you can use sine and cosine. Okay. So so if you're looking for B, so you got sine of angle B or sine of theta equal to B over C. Okay, so you can have a sine of 58 degrees 40 minutes equal to B over 15.0. Okay. Okay, so you can do a cross multiplying. So B equal to 15 times sine of 58 degrees and 40 minutes. Right, just cross multiply. Okay, so from here you can just use your calculator. So 58.40. Again, for my calculator, I have to convert into decimal degrees. Then I have to take the sine of that. Basically, well, for my calculator, I have to work backward. Okay, times by 15 equal. So B equal to, and this one, okay, it doesn't say how far, so this one kind of has three significant digits, so I'm going to just follow that. So B equal to 12.8 millimeters. Okay, so I'm going to put up here, so 12.8 millimeters. Now to do A, okay, so to do A, to find A, I need to use a cosine. So cosine theta equal to A over C. Okay, so cosine of 58 degrees 40 minutes equal to A over 15.0. So you can cross multiply. So A equal to 15 times cosine of 58 degrees, 40 minutes. Okay, then just use a calculator. So again, I'm working backwards, so 58.40 is converted to decimal degree. Take the cosine of that, times by 15 equal, so A equal to 7.80 millimeters. Okay, so again, I'm using 3 digits. So it would be 7.80 millimeters. And, oh, by the way, this is number 37. Okay, so this is number 37. Okay, let's go to the next one. Okay, number 39. Okay, so I'm going to draw the picture first. Okay, so using the same picture, so A, B, C, A, B, C. Okay, and again, so whenever you're solving for a triangle, go and write down your capital ABC and a small ABC. This will keep you organized to see what you have and what you're missing. Okay, so again, angle C is 90 degrees, right? It's a right angle, so it's 90 degrees. And giving theta, so this is a theta over here, so that's B, so it's 83.7 degrees. And small b is 3.21 kilometers. Okay, so again, using the complementary angle, so use 90 minus that will give you 6.3 degrees. Okay. So once you get the angle, now you can go and use the, so to find A, so B is giving, and so to find A, you can use the tangent, so this would be tangent. Okay, so write down so tangent theta is equal to B over A. So you can write down your relationship first, write down your function, then you can start to substitute things in here. So tangent of theta, so 83.7 degrees equal to 3.21 over A. Okay, so if you do the cross multiplying, so you got A tangent 83.7 degrees equal to 3.21. I cross multiply, then you divide, so A equal to 3.21 divided by tangent of 83.7 degrees. Okay. Okay, so this is decimal degree, so it's not too bad. So I can just go straight forward. So I got 3.21 divided by 83.7 degrees tangent equal. Okay, so I got A equal to, let me see. This one has 3 digits, so I'm just follow that. So it'd be 0.354. Okay. Okay, so I'm going to put over here, so 0.354 kilometers. Okay, and then to find C, I don't want to use Pythagorean Theorem because this is already running off, so this is off already. And if you use that to use that to find the Pythagorean, and you use Pythagorean Theorem to find C, you're going to be off by a lot more. So I'm going to use this function. Okay, so for this one to find C, so I know this, and I'm looking for this. So the relationship between them is sine. Okay, so sine theta equal to B over C. So substitute, so sine of 83.7 degrees equal to 3.21 over C. Again, cross multiply. And then you divide, so C equal to 3.21 over sine of 83.7 degrees. Then after that, use your calculator. So 3.21 divided by 83.7 degrees sine equal, so it'd be 3.23 kilometers. Okay, and that's it. Now you can kind of check, you can see how accurate these are by using Pythagorean Theorem. So I'm going to try that again. This is something extra. So 0.354 square plus 3.21 square equal, and you take the square root. In this case, it comes out exactly the same. Okay, so this one's pretty accurate. Okay, so you can use Pythagorean theorem to get that. Okay, let's go to next one. Okay, so again, the picture, in this case, again, if this is B, so this would be a B over here, okay? The A is always facing the A. Okay, so again, to solve the triangle means you're looking for all three angles and all three sides. In this case, this is the right triangle, so right away we know angle C is 90 degrees. And let's see what else is given. Okay, so theta is 71.5 degrees. So theta and angle B are the same. Okay, and so right away, okay, that's good. Okay, so B, small b is 12.8 inch. So right away you can find this angle over here. So this would be 8.5 degrees. So double check. Yeah. Okay. Okay. So now let's go and use. So we know these, and so if we're looking for A, the relation between it is tangent. So just like last time, so tangent theta equal to opposite over adjacent. So you can always write down your formula and then you substitute, right? So tangent of theta, or theta is B, right? So B 71.5 degrees equal to B 12.8 over A. So cross multiply. Okay, then you divide to get rid of the tangent. So A equal to 12.8 divided by tangent of 71.5 degrees. Okay, so get your calculator. So 12.8 divided by 71.5 degrees tangent equal, and this would be, so A equal to 4.28, and the label is inch. Okay. Okay, and then to find C, so if you're looking for C, the relationship between these two is sine, so I'm going to use sine theta. Sine theta equal to B over C. So sine of 71.5 degrees, again, theta and the B are the same. Okay, and so equal to 12.8 over C. Cross multiply. Okay, and then divide. Okay, then use calculator. So 12.8 divided by 71.5, sine function of that equal. So C equal to 13.5 inch, right? So 13.5 inch. Okay, so I'm going to just do a quick check to see how close we are. If we were to use the Pythagorean theorem from here. So you got 4.28 square that plus 12.8 square that equal, take the square root. Yeah, come out. So in this case, it still come up exactly. So that's good. Okay, let's go to the next one. Okay, number 43. Again, let's go and get our picture. So that's an angle B. And the reason I know this is B because this is B. B and B, they are facing each other. Same letter have to face each other. Okay. Again, keep things organized. You want to write A, B, C. That way you know what you have and what you need to solve. Okay, so right away, this is the right angle, so angle C is 90 degrees. And let's see what else is given. Small b is 63.8 feet. And C is 134 feet. and you're going to be nearest to the nearest 10 degrees. Okay. Okay, so we know these, okay? So right away we can find this angle first. So the relationship between these two is a sine function. So you're going to get sine theta or sine b. Okay, in this case I'm going to use b, doesn't matter. So sine of b equal to b over c. So sine b equal to 63.8 over 134. Okay. Okay, so I'm gonna divide this first. So I got 63.8 divided by 134, push equal. Okay. So I have sine b equal. You don't have to do this step. I'm just showing you so you can follow what I'm doing. Equal to 0.476119, whatever, right? And then don't erase that. Just use that equal second function of that. So second sine of that. Okay. And so angle B is going to be equal to 28.43 degrees. But they want you to use the DMS. So you have to convert to DMS. So go second DMS. So equal to 28 degrees, and it's at the nearest 10 minutes. So it's 25 minutes. So nearest 10 minutes would be 30 minutes. Okay. So this would be 28 degrees and 30 minutes. Okay, so you have to follow the instruction. Okay. And after that, you can use 90 minus that. But it's kind of hard to do on this calculator. So I'm going to keep that. I'm doing minus 90. I'm just going backwards. So minus 90 and take the negative of that. Okay. And convert. So this would be 61 degrees and 30 minutes. Okay. So you can use 90 minus that to give you that. Okay. But we still have to look for the small a. Okay. Now to look for small a, I guess you can use Pythagorean Theorem and go back and use Pythagorean Theorem, or you can use the cosine function. Okay, so that's going to do that then. So I'm going to use cosine theta. I'm probably not a good idea because this number is already off a little bit. So use that; it might affect the answer a lot. So I'm going to just use Pythagorean Theorem: a squared plus b squared equal to c squared. So you put in the numbers in here. Looking for a, so I'm going to move this over. So a squared equal to c squared minus b squared, right? And you take the square root. Okay. So a equal to square root of c squared minus b squared, right? So basically the reverse of the Pythagorean Theorem. Okay, so I get 134 squared minus 63.8 squared. Okay, that's going to do that. So 134 squared minus 63.8 squared equal, and you take the square root. So a equal to 117.8. Since there are 3 digits, so I'm going to round off to 3 digits, so it would be 118 feet. Okay, so it would be 118 feet. Okay, let's go to the next one. Okay, so we can draw our triangle. So that's the b and the theta. So this is small b, small a. This would be the big A, and this would be the small c. Okay, so let's get things organized. So A, B, C, and a small a, small b, small c. Okay, so big C is 90 degrees, and let's see what else is giving. Small b is 132 miles, and small a equal to 108 miles. Okay, so from here right away, I'm going to use Pythagorean Theorem, okay, to find c. That one's fairly easy. So 108 squared plus 132 squared equal, and take the square root. Okay, so I get 170.55, so run it out to 171 miles. Okay. Okay. Now this is giving, so the relationship between it is tangent. So tangent of b, or tangent theta, equal to b over a. Okay. So tangent B equal to 132 over 108. And then from here I can go and find the angle already. Okay, so to find the angle first, I get 132 divided by 108. Now push equal. So tangent, okay, let's do one extra. So tangent B equal to 1.222. Okay, and now without clear, you just go second tangent of that. Okay, so B equal to, and this one they want the nearest 0.1 degrees. Okay, so it'll be 50.7 degrees. So this would be 50.7 degrees, and to find that, you just use 90 minus that. So I'm just minus 90 and take the negative of that. Okay, so it'd be 39.3 degrees. Okay, and that's all the answers.